Hello, I'm Steve Olson, the Manager of Training Services for Mesa. In this video, I'd like to take a look at a case study I came across recently of an interesting flat pattern. So recently, I was teaching a sheet metal class with a customer, and they had a part that looked like this, and they were trying to figure out how they could generate a formed and flat pattern for this model. And after working with a coworker of mine, we came across a good way to be able to create a flat pattern for this part and also still have the form and the flat. The idea is that we will create a sheet metal part that will help us represent the flat pattern of it. However, it's not going to have the corners, and we'll be able to use the derived part to create that, and everything will still be linked up, and we'll have a good flat pattern and a good model. So let me kind of start from scratch here to show you the workflow. So I'm going to start a new sheet metal component. And working with the customers, kind of just roughly what the part looked like was, it would be kind of like a contour flange that just kind of had one leg come down, one leg come straight over, another one come down. And I'll set up my constraints here. Align dimension, we'll go with 5. Another align dimension, we'll go with 4 on this one, and we'll just use 135 degrees here and 135 degrees here. So we'll use a contour flange to make the middle part of the bracket. Go mid-plane, we'll say maybe 3 inches here, and that looks pretty good. Say okay, and then we just create flanges down the one side at whatever angle seems to make sense. Now one thing here is I'm going to turn off the auto mitering, which will create the right effect on this one, on this angle here, but on this one it's going to create interference. So I'll use the offset options, or the override of the width extents to offset. Set the one side to 0. Actually, this one we want to be 1/4, and this side to be 0. I'll do the same thing with this one, but just create that gap in the middle. So that looks good. And now I can just mirror those over to the other side. So I'm going to mirror those over to the other side. Actually, just nice to be able to use this new offset or origin plane to pick my mirror plane. You can see it's just going to mirror over to the other side. Now in this case here, when I go to create my flat pattern, it's going to have those gaps. But we've had some functions over the last couple of years to be able to fill those in and make our flat pattern look accurate to what the flat pattern should be for this component. So let's go ahead and fill that in. So I'm going to tell it to start a sketch. Give me the warning about edits the flat pattern won't affect the part, but that's fine. And I'll just project the whole face in and just draw little rectangles here to fill in these gaps. So now I have that, I can finish my sketch. And I'll tell it to create an extrusion where it'll extrude those profiles down 1 material thickness. So you can see right now it's extruding them all up 1 inch, which isn't what I want. I'll tell it to flip it over. And here in this field, I'll tell it to use thickness. So in this case, my flat pattern is going to be right. It's going to be filled in. If I go to my folded part, you're still going to see those corners, but we'll fix that here in a second. Go back to my flat pattern, and everything looks good. Now, one thing about this is in the folded model, I can't fill these in this model because it's going to end up affecting my flat pattern, even though I could use some tools to do that. So what I'm going to do is I'm going to save this. I'll call it bracket 1. So now I'll create a new standard part file, and I'll derive that model in. Just bring it all in. So now I can use sweeps and lofts to fill those openings in, mirror them over the other side, and I'll have two different models that represent what I need, and I can represent those both in the drawing. So let me kind of finish that real quick here. So I'll create a 2D sketch on this face, and I can project in these two faces. And I can do a sweep this profile and this profile along this path. That one fills that in nicely. I tried the same thing on this one down here, and for some reason it doesn't like it as well. So what I'm going to do is I'll do a loft. And either way, these would work. So I'm going to go ahead and create a sketch here. I'm going to project in these edges, and again, kind of practicing or kind of making sure this all worked out. If I projected the two closed profiles, the software didn't seem to like it so much. So I'm going to just do each individual edge. I'll create another sketch over here. So now that I have these, I can create a loft to fill that in. So just 1 second here. We'll do a loft. I was trying to see the face profile, but if I hover here a second or even use my right click to select, say, select other, I want the curve. I'll say add, come over here, hover over one of these, right click, select other, and I want the curve again. So I'm going to try to do edge to edge or face to face. I'm going to say I want to add some rails. There we go. We'll click to add some more. We'll do the bottom edge too, just to be on the safe side. Say OK, and now I've got those filled in. So I just need to then mirror them over to the other side. So I'll do one more mirror, and we'll be done. So mirror. I'll get my sweep and my loft. Use my XY as my mirror plane, and now I have that all formed. Now realistically, this is going to be hard to model, or the way they're going to be manufacturing this is a little bit of an oddity anyway, but this way I can have a completely appropriate looking model for the form, for the drawing, and also have a flat that looks perfect for the flat pattern as well. I want to thank you for watching this video. If you have any questions or comments, please feel free to reach out to me at my email address on the screen. And again, thank you for watching.